Welcome to the launch of the ICEA Semiconductor Product Design Leadership Forum. I'm reminded of Arthur C. Clarke, a British science fiction writer who once said that any sufficiently advanced technology is indistinguishable from magic. And that's what we are here to talk about today, semiconductors, one of the most advanced technology we have crafted, made through one of the most complex supply chains devised by humans. These tiny products with features as small as 3 nanometers are more than 25,000 times smaller than a strand of a human hair. And they power everything from this iPad that I'm using to refer to my notes to the phones that are in your hands right now, or even the car that you drove by here today. Here in this room right now, we have representatives from the government, semiconductor, DRI companies, electronics manufacturing companies, international industry associations, venture capitalists, and research and academia, bringing together the vast array of stars in formation to discuss and deliberate how India can develop a strong base for fabless companies. As we move into the opening session of our conference, it is my distinct honor to welcome our dignitaries to the stage. Let's embark on this journey of knowledge sharing, collaboration, steering India towards a brighter, more innovative future in semiconductor design. Ladies and gentlemen, I'm delighted to introduce Shri Pankaj Mohindroo, Chairman of India Cellular and Electronics Association, a prominent figure in India's electronics industry. With an excellent academic background, Shri Mohindroo has had a distinguished career over 3.5 decades, contributing to diverse industries from telecom to agriculture. As a visionary supporting the government of India, he has burnished his reputation as a wise counselor in the mission to establish India as a global manufacturing hub. Sir, please join us on the stage. Now I would like to invite the chairperson of the Semiconductor Product Design Forum, Dr. Sandeep Kumar. Dr. Sandeep Kumar is the CEO of L&T Semiconductor Technologies Limited, India's largest semiconductor product design company. With over 35 years of experience in technology, he has been instrumental in driving global leadership in energy-efficient chip design and innovation. Under his leadership, LTSCT is pioneering a new era of fabless semiconductor innovation, focusing on designing high-performance, energy-efficient semiconductor technologies. It is also my privilege to invite a figure of national repute and profound impact, Dr. R.S. Sharma. Dr. R.S. Sharma, ICA's chief mentor and our guiding light, is a distinguished member of IAS 1978 batch and has been at the forefront of India's digital revolution. His leadership in spearheading the implementation of Aadhaar and the CoWIN app have been groundbreaking. An author and thought leader, Dr. R.S. Sharma's insights continue to influence public policy, technology, and governance. We are incredibly honored to have you here with us, sir. Finally, we are very thankful for the presence of our chief guest, Shri S. Krishnan ji, Secretary, Ministry of Electronics and IT, Government of India. An esteemed member of the 1989 IAS batch, he has served with distinction in various capacities. He previously served as the Additional Chief Secretary in Commerce and Industries and the Finance Department of the Government of Tamil Nadu, where he was the founder CEO of the Tamil Nadu Infrastructure Development Board. A visionary leader, S. Krishnan ji has been instrumental in driving development and governance both in India and internationally. Now that our distinguished speakers are seated here, I invite them to share their valuable insights with us. May I please request Pankaj sir to deliver the opening remarks for the conference. You can use that mic, sir.
They say that the lid of any organization, any project is the leader. And the people on my right, I mean, I'm so happy that, you know, that lid is very high. The pioneering Dr. R.S. Sharma, we are blessed to have a great secretary like Mr. Krishnan. And for the Semiconductor Product Design Leadership Forum, I think there could be nobody better than Sandeep. And he's taken up this massive challenge. India's always been behind our neighbor. I remember 3G, we came a decade after China. 10 years after China, we launched 3G, and we suffered 2G for a very, very long time. But we caught up, I think, at now 5G penetration, at least on the consumer front, not on the innovation and technology front, at least on the consumer front, we are experiencing good speeds, good 5G rollout, and that's been a fantastic experience. And I think Dr. Sharma gets a huge credit for that in his when he was handling TRAI in the sector. Basically, two, three things I want to highlight today. We are facing very testing times because you see the all eggs in one basket strategy, which we thought was right for India. Somehow that has got disturbed with what is happening. So we have to come up with a big, beautiful plan. I mean, no pun intended, but we we also have to come up with a big, beautiful plan. Fortunately, in electronics, we do have a big, beautiful plan. And it is slowly getting rolled out. And every pocket of value creation, value addition is being studied, looked at, and will get rolled out in times to come. Smartphones is the pillar of our volume and scale. We'll end up with $75 billion. And that has also not got impacted, fortunately, for the time being. So we expect exports to be very robust. But all other sectors, which is IT, hardware, consumer electronics, appliances, hearable wearables, auto electronics, medical electronics, I keep stressing this again and again and again so that attention of everybody keeps going on to these sectors, which are very important, because we cannot be a sectoral economy. In electronics also, we have to fire on all cylinders. And now we are working on the foundational industries. One fab, maybe two fabs, and also the many packing units coming up. The greatest value creation, as all of you know, is in design. And when we studied our neighbor, we jumped out of our skin because we saw that there were more than 3,000 companies. And I mean, no better leader than Sandeep to tell you that journey, how they did it. So more than 3,000 design companies. When we study 64 verticals of ASICs, you don't see a Western company in almost all 64 of them. The top 10 companies, top 15 companies are all from our neighbor. So, but can we do it? I think, yes, we have the capability of doing it. We have tremendous belief that we can move on from being a trader and labor arbitrage country to creating real core technology. And I think for that, we have to shake off our obsession with, the West. If you remember the movie Mangal Pandey, when that one good British captain who was humane, he was worried about Mangal Pandey, and he was saying comforting words. But Mangal Pandey, stretches out his arm. He says, it's this color which is the only problem. It's the color. So we have, because our children study there, our families are connected with the West. So, and, we still carry that colonial thing. So we have to shake it off. We have to understand how value got created in the East. And fortunately, we have very deep engagements with Taiwan, and we are understanding what is going on. It's a decade, more than a decade experience of working with Taiwan, and that has been a good experience. We've been doing an exercise on disabilities, and I must share some good news with you. India has covered a lot of ground in the last 7-8 years on mitigating disabilities. We are ourselves surprised. Areas like infrastructure, power, quality of power, the rate of power, the industrial infrastructure in certain states. And I think Tamil Nadu and UP score tremendously. The guidance guys have turned up here also, Rajesh. Like wherever you go in the world, they are somewhere, you find one representative, which is great. So this is what the states should be doing, at least 5 or 6 champion states in this sector. Semicon is also very unifying because all verticals come together. Because you see, we are very smartphone focused. We were a very smartphone focused association. We were nudged to move to more electronics, etc. And today the mandate we have taken is that the pockets of value creation, we will focus on all the pockets of value creation in collaboration with the government, with MeitY. And we are fortunate that MeitY is playing such a significant role in building the nation. Thank you very much. Rishabh?
Thank you, sir, for your kind address. Your words set a perfect tone for the discussions ahead. Now we have Dr. Sandeep Kumar with his presentation on championing semiconductor innovation and IP creation in India.
Thank you very much. Welcome. Good morning. So, everybody from here is in semiconductor almost. I don't have to teach anything. I think India has an opportunity. The government, MeitY, ministry, in the last 2-3 years has created a big push. That push resulted in India being put on the map. Now one could say, ये use करना,
Slides move करने के लिए.
ये सीखना पड़ेगा. Semiconductor है ना इसमें. Left, right? Yeah, I worked at TI. I joined them in '84. '84 was also the first time TI set up their operations in India. It was the first company to come to Bangalore. And now, when TI opened their offices internationally, what they used to do is find a resort. So they would put it in Nice, they would put it in Freising. So it would always be a resort so that the talent that was hired there would not leave. And second, there was no other company over there. So a combination of people having a good life. But Bangalore, everybody came, right? So now Bangalore is what it is. It started with TI. The interesting part is that India now has 20% plus of design resources, IC design resources in the world. The biggest design centers of every major multinational is based in India. But the products belong to the multinationals. They don't belong to an Indian company. So tomorrow, any one of these multinationals, through political pressure, or geopolitics, could move out. Despite that large force, there was not really a vibrant ecosystem of semiconductor startups. And India was never on that map. So to me, the government creating this buzz around and actual investment into the capital, the fab capital, finally put us on the map. But how do you fill up those fabs? How do you fill up those OSATs? And so it's really important to do this second half of the equation, is to create a deep pipeline of product companies out of India. Because the foreign product companies are not so, I mean, you might bring some, but very difficult for them to, deal with the geopolitics of their own country. So anyways, so critical, we import a lot of semiconductors, we have strategic vulnerability, but we have untapped potential. Right? So if you think about it, India is growing and the electronics will grow through all the efforts. Actually, by 2030, it will be consuming over $120 billion of semiconductors. That is more than 10% of the world's consumption. In 2030, it's expected to be $1 trillion economy. If we create this fabless ecosystem, I believe we can create 1 million+ jobs. This could be the next, IT, and contribute, in 2030, India is supposed to be 7 trillion economy. You could visualize this direct and indirect industry contributing 3 to 5% of GDP. And the semiconductor industry in general is very performance driven. What that means is if you can sell in India, then you can sell globally. Because it's the other way around as well. Customers in India, system makers in India, will not adopt a subpar chip or IC. They will keep using TI or NXP or Infineon or Renesas because that is a better performing chip. And ultimately it is going into a product, any one company is making a $1, $2, $10 chip. And that is going into a system that could be $300 in a phone or $10,000 in a car. So nobody in those systems is going to compromise on the quality and performance of that chip. So you need to develop something that is leading edge. And if you develop something that is leading edge, then you should be able to sell globally. So there is no reason for it to be restricted to selling in India. So that's how we are setting up L&T, but my talk here is more about how to create this ecosystem of thousands of companies who think that way. It is not just about serving the Indian market. If I want to make a camera chip, it should be ready to serve the global market. If I want to make a motor controller, it should work for the global market. If I make a power device, it should work for the global market. So that's the... So we've been having a lot of discussions, and there is a model that we used, I have used quite often in US, also in Japan, also in Chile. So you have to create an innovation pipeline. What does that mean? These technologies, semiconductors are built up on a foundational technology. If these startups try to create the foundational technology, they will be here for 10 years, first creating the IP. So you have to enable these startups with solid IP. That IP can come from Indian institutes, but can also come from foreign institutes. So we need partnerships with the Fraunhofers, we need partnerships with the ITRIs in Taiwan, and the various global entities that can provide IPs to our entrepreneurs. And it has to be done in a way that the entrepreneur does not spend 2 years negotiating that IP. So that's one element we need to create. Then once the entrepreneur or even in a bigger company for that matter, it's not just about small companies. Once they start, then you have to create, their value is in the design. So you have to enable the rest of the ecosystem. So we have people from ARM, we have people from EDA. So that should all be streamlined. The example I will give is, 20 years ago, China decided they want to get into semis, right? 25 years ago, they set up SMIC. I was a VC at that time, one of the first investors in SMIC. Then they said they want to create a design ecosystem. And they set up a IC design software park, design park in Chandu. And they brought in all the surrounding ecosystem and put it in that place. So they even built a fab right next door. That fab was later acquired by TI and then sold off to SMIC. But there was a fab, there was a packaging. The packaging site was actually built for Intel and then acquired by the government. And all the EDA tools and infrastructure, and so the startups would come. They would have office and then they would start working. And everything else was enabled for them. So that's the kind of structure or idea that we should formulate in some way. And then we have, the third part, people create products. So you have IP, you have entrepreneurs, and you have the infrastructure. Then the third part that comes into play is semiconductor companies take 2, 3, 4 years to, this is a long design cycle, a long sales cycle. And by the time you become profitable and self-sustaining, you are spending a long time and you need capital to survive that. In fact, India, there's been many companies that start off as product companies because the founders dream of building a product company. Because of the scarcity of capital, they over time become service companies. Because they have to, you have to continue to pay the bills and you have to do something, and if the financing runs out, you need to. So that's how most of them evolve. So we need to address that through some funding mechanism. And that funding mechanism we have tried out in Japan. I set up the funding mechanism for NATO. So we can bring some of that knowledge and leverage it. So overall, this Semiconductor Product Design Leadership Forum, there is another last element which I didn't cover in that previous slide. The last element is that entrepreneurs are engineers primarily, and they know how to build a product given the IP. But then even in the US, this is not an Indian problem, this is a global problem. They don't know how to sell that product. They don't know how to reach the market. So this go-to market has to be enabled for them if we want them to succeed. And that is a very crucial component, the industry relationship, and how do you create that upfront mechanism to go to market. So we put together a program where the problem statement is defined by the industry, the technology is defined by the IP or IP company, the entrepreneur comes up with a business, then you bring in a business team into it, and then the industry that said this is the problem, they commit to buying. So this could be a biomedical company, it could be an automotive company. So there is certain commitment that and that automatically, if you create that pool, the investment comes. The VCs invest. So that is kind of a mechanism that we have used quite often in the past. And this is how we set up the incubation in Chile and in Japan. So this is the early part. How do you create that? So you have to assess the IP capabilities, define the problem, create a think tank that sets up that solution for that problem. You create a design studio and fund 20 people with prototypes. They come out, and then you create a company out of it. And then you have to put the, entrepreneur starts. A lot of them are stubborn. They want to do it their way, but they don't know marketing. You have to bring in marketing. They don't know sales. You have to bring in sales. They don't know finance. But they think, engineers, one challenge about engineers is they think they know everything, right? And number two, the challenge with engineers is they think that's the only thing of value, right? Everything else is just, So you have to fix that and create a real company out of it. So this is a model we had used, and you create an innovation pipeline that feeds into the entrepreneur. You have to train them, so you need a training ecosystem. Then you have the market assessment, technology fund. So my suggestion is and we'll bring in other people. We will have a kickoff forum in 2 months where we will bring in all the ecosystem players and actually put some framework around each of these. And we want, the major companies to participate, the government to participate. So then there is a financing. One suggestion is to use the Japan model. In Japan, it was interesting. 10 years ago, 2015, the Japanese government reached out and said, I've done a lot of work in Japan, so they reached out and said, we are number 2 in IP in the world after the US. But we are number 100 in the startups that succeed out of here. We are still relying on the Mitsubishis and companies that have had 150 years history. How do we change that? And they were pouring a lot of money into creating that ecosystem. But that money was being, they thought they were doing good, but actually it was hurting because the entrepreneurs were getting $1 million every year on grant funding, so they had no reason to grow and succeed. There was no scarcity that says you have to solve this problem. They were happy with a 10-people company that kept running for 10 years. So what we changed is, instead of that funding going direct, we brought in VCs and said, the companies you fund, the grant funding will only go to the companies that have a VC backer. Because the VCs have to do a multiplier on the money, whatever, even if it is a smaller amount. And they were not coming to Japan because they could put money in California or San Francisco instead of Japan and get a better return. So we created a risk profile of Japan, and that risk profile said it is 7 times more riskier to put for a VC to put that money into Japan, in a Japanese startup. So the government said, okay, we will de-risk that. So we will give $6 for every $1 that you fund. Now your money is de-risked, but since the VC still has to return that dollar back to whoever was their LP or the people who funded them, they still had to make sure the companies were successful. So it created a system that enabled financing and risk management. So that's the one idea, but there are other ideas. So what we want to do is, as we work through this as a group, we will need to solve the IP problem, the partnership problem, the ecosystem problem, the financing problem, and create a platform that everybody is behind. And then talent development. So we need to do university partnership, industry training, but very important is a global exchange program. So both in China and in Chile and in Japan, all 3 places, we put together a program. In Chile, what we did was we said, okay, the local ecosystem is not yet fully developed, a startup ecosystem. So how about we bring American companies to Chile and fund them for 6 months? Now the goal was not to bring the companies. The goal there was to create that knowledge and hunger and appetite to create startups. And so there was a cross-cultural diffusion of that knowledge. The companies are working and they work differently than the Chilean companies, and over time that evolved. In China, they did a different approach. They said, we will finance any company to move from US or anywhere. So one of my companies I set up in US, I moved to China, to Guangzhou. And they paid $20 million to set up the fab and move all the IP from US to China. So that I was just one out of thousands, right, that they created. So that is another mechanism we could leverage. And in Japan, what they did was, when we set up the program, they said, okay, the management team is lacking because these are all very high-tech, very deep-tech entrepreneurs, but they don't know how to scale. So every startup that was set up, we brought in an American management team. So different models can be utilized, but you have to create that, pipeline to create success. And that to me is, over time it will have its own, people will learn and you will have enough people who know how to do it here. You don't need to, it's not something you have to run for many years. And then some focus areas, I think for us, one important thing is, in my mind, is these startups, because they have to compete globally, need to look at what are the future trends, not just, can I make a BLDC controller for the fan? It's important, but that is not the big advantage. So we have to look at CPUs, GPUs, NPUs, AI processors, and look at how over time we create that capability in India to where, so IoT and edge compute, 5G, 6G, how do we create the, ORAN systems, etc. And then automotive is gone from, used to be painful to, it's still very painful, but 40 years ago, the content in a car was about $100 electronics. Today it is $2,000. The car itself, 40 years ago, there were 60 million cars. Now there are 90 million cars. So the number of vehicles hasn't gone up, but the market has exploded because it went from $100 per vehicle average to $2,000 per vehicle average. And it is now, even Xiaomi makes a car because it is basically a cell phone on wheels, is the way they envision. So if you look at the latest EV coming out, it is a cell phone company that has rolled out a car. So idea here is a roadmap. We want to spend this year and establish by next year a foundation. What is the policy? What is the infrastructure? What are the methods? Work as a group. And then bring in IPs and technologies and create startups. And then scale those startups and create, a global leadership position over the next 10 years or so. It's a long journey. Sometimes we want to get results in a few years, but I think to get where we want to, this will be a 10-year type of journey. And we need to think through this that way versus let me see if I can generate quick results, because quick results sometimes doesn't lead to the right foundational layout. One other comment I have is, what happens in different parts of the world. Each country had their own approach on how they became big in semiconductor. So Taiwan went after manufacturing, Korea went after memory chips, US has been a design and R&D center, and China went after scale and speed. Trying to compete with them on any of those, very tough. So thinking we will beat Taiwan on manufacturing or beat core chip design, or we can go faster than China, we may. But you have to create your own path. And I think the path that would be very relevant is understanding the system. Because these semiconductor chips now drive systems. So creating not just a chip, but a solution based around that chip. To some degree, that example sits there. NVIDIA is an example of a company that sells chips but creates a system solution. They create the software, they create the ADAS, they create the data center application, they create the full application. But they sell the chip in the end. The money is coming from the chip, how they monetize it. But their expertise, why people are stuck with it is, and same thing happened 20 years ago in the cell phone, where, Qualcomm would make the reference design, and everybody in China would just copy that reference design and then delete from it, right? It wasn't an exact copy. So if the Qualcomm reference design had 5 cameras, they would remove 4 cameras and make it cheaper, remove the accelerometer and make it this way. But it was, the system knowledge was coming from Qualcomm. So I think that is the approach we as companies, startups over here, any market you go after, we look at the system, make the best system, the semiconductor sells because you made the best system solution. And then give the system away for free. Everybody can make that system because my chip will go into it. So you don't need to monetize the system. That's one thought process I have, and again, these are my ideas, but we will all get together as a group and hammer them out and then come up with a common idea on how we go forward. So I think we want to set the goal of this is a Vision 2035. Create 100 successful startups, create 1,000 startups, but 100 successful companies. That should be, in different stages, but scaling, and we will figure out how to help them go to market. As L&T Semiconductor, I'm committed to, we have a global operation, so we will help every startup or every company who wants a GTM, we will work with them on the GTM. Help them go to the international markets, wherever they need to go. So that's my talk for today. I welcome all of you to join this effort. We need all of you to be part of this effort. It's not just, it won't happen without a group that will need to pull this off. Thank you very much.
Thank you so much, Dr. Sandeep, for that incredibly insightful presentation. Now, please join me in inviting our chief guest, Shri S. Krishnan ji, to give his keynote address. Sir, please.
Dr. Sharma, Dr. Sandeep Kumar, Shri Pankaj Mohindroo, and many members of the audience, many of whom are good friends and colleagues who have worked on a number of aspects of what needs to happen in the electronic space. Let me first congratulate ICEA for stepping a little beyond their comfort zone and taking on a role which is on something which is very critical for the country. I think both Dr. Sandeep Kumar and Mr. Mohindroo emphasize the importance of design and where we go with design and why that is so important in terms of value addition. There have been a number of occasions when we have talked about the importance of India becoming a product nation and a design-led manufacturing nation. And that is clearly critical because that's where the value lies, and that is where I think, in a sense, the overall sense of both autonomy and sovereignty can prevail, and which in today's geopolitical circumstances is so important. And we need to navigate this space very carefully, and I think that is a very key insight that Dr. Sandeep Kumar delivered in the course of his very thoughtful presentation. Because you need to navigate a space where, not everyone is wanting you to be either sovereign or autonomous. And you have to find your way through these interstices, find your way through the gaps, and get to a place where you can achieve what is clearly a legitimate objective. And maybe a little at odds with what others view it as, but something which is very significant and important. And if at all it is possible in any space, we talk about product design more generally, we talk about design of various products more generally, not just in the electronic space but elsewhere. But one area where it is definitely possible is in the area of semiconductor design, simply because we have the human resources in this country to enable this to happen. And with those kind of human resources, I think clearly this is a space which we need to work on. And given all the investments that we've made in the India Semiconductor Mission, through the India Semiconductor Mission, on establishing fabs and the ATMP units across the country, it's important that these fabs will have to eventually get filled. They have to get loaded. We have to have designs which will actually get there. And that is something which we need to target for. And those designs, not only on our fabs, but fabs elsewhere in the world, for use in India, I think is very important. And there are critical spaces where we need these kind of chips which are designed for India. So I think nobody will doubt that this is a very key space where we need to sort of take a significant forward step. And in that sense, having this ICEA Semiconductor Product Design Leadership Forum being launched here, I think is a very significant move. It brings together a number of people who are coming into this key element. And in a sense, many other aspects of the ecosystem in India are coming together. We've had several attempts at having a semiconductor manufacturing base in India, which I think has come together finally in the Indian context after many attempts at trying to make sure that in the semiconductor product space we have a real launch of a business in a way that makes a significant difference for us. We've tried all the way from the 60s. Just as I walked in here, Dr. R.S. Sharma reminded me of the efforts that were made about a decade ago. I recall 2 decades ago an effort which was made, which was ill-started. All of these have been efforts that we've made, but finally I think it's fair to say that we've grounded what needs to happen. We've made sure that there is going to be a fab. The first Indian chips are going to be rolled out in the course of this year. The minister was at an event last week in Gujarat where they load out the first test chips. Both Tata Electronics and Micron, both of whom are present here today, have been important elements in this. Other semiconductor companies are present here, and I think they are part of a very important journey. We finally reached double digits in terms of the number of companies we have supported. We've got to the number of 10, maybe 2 or 3 more, and then we should be fully absorbing whatever we've done in the India Semiconductor Mission, the phase 1 of the mission. Which brings us to what happens next and how do we do this. An important part of the India Semiconductor Mission was also the money that we invested and what we put down in the design-linked incentive scheme and what attempt was made there. MeitY in some senses has been, and this is something I think we shouldn't forget because that is providing us some kind of a base on which we can build. Whether it is the effort to establish academic fabs through the nanoscience centers across Indian Institute of Science and the 6 IITs across the country, whether it is the Chips to Startup program, which today makes available the EDA tools, which are so important for this industry across almost about 350 enterprises. And I recall a few months ago when we were reviewing the progress of the design-linked incentive scheme, and the question I asked was, all right, you've given it to so many institutions, so many students, what is the usage? And I'm very happy to report to you that I understand just in 2025, nearly about 1.2 2 crore hours of use of this EDA tools has been achieved across these 350 institutions in the country. These are both academic institutions and also institutions which, many startups, almost 100 startups, which are using these EDA tools to generate a whole host of things. And what is interesting is it's spreading to places which you would otherwise not think is possible. I visited NILET's center in Aurangabad, Chhatrapati Sambhaji Nagar as it's known today. 2 things struck me. One, of course, is that you have a bunch of young MTech graduates and others working under the work-based learning program and actually building chips. And they're from all smaller towns and cities spread across Maharashtra, the central part of Maharashtra, spread across Telangana and northern Karnataka, who had come together there and they were doing this. And it's quite a remarkable effort. The other thing which struck me was that this was a center which was set up in the mid-80s under the leadership of Mr. Nambiar, who was then the Secretary of the Department of Electronics, one of the early secretaries. And it sort of emphasizes, in a sense, what we are doing today, that these NILET centers were set up, or those days they were called something else, were set up with an MTech program with design and an ITI and Polytechnic program of people who will actually work on the shop floor to put all these designs together. So fairly visionary in terms of understanding that both these elements of what needs to happen are important. And in that sense, we are again trying to do the same thing, and this time I think we should achieve a significant degree of success, and which is one reason why the design-linked incentive scheme. And there have been extensive consultations. Dr. Sandeep Kumar himself has presented this both to my minister and to all of us in a great deal of detail as to what this idea is. In addition, we have been speaking to a number of experts, many of whom are present in this audience, as to how we can recast this entire program, how we should be able to be more liberal in our approach, both to the kind of companies or enterprises which are selected under the scheme, the way in which we release the money, the amount of money we provide as a grant, and most importantly, how do we ensure access to risk capital. All of these are things that we are working on currently. Recently, the government has also announced the RDI program within the ANRF, within the Anusandhan National Research Foundation, and we have had very good discussions with the Department of Science and Technology to make sure that that program is also leveraged to make sure it supports the semiconductor design industry, and then we supplement it from MeitY. So it's an interesting approach that we are taking to make sure that it all comes together in a way that there's more funding which flows through a convergence of programs to this particular area, and also involves more and more institutions. And I think it's bringing together more institutions which becomes critical in this space and something that we can work with. Therefore, I really see a wonderful opportunity for industry, represented by many of you here today, academia, research labs, including CDAC and various other labs which we have in the government system, and also possibly in due course of time in the private sector, to work together to really make this happen, so that India becomes truly a design location for the world. And we just don't design only for companies from the rest of the world, but we also design for India, and we design, as Dr. Sandeep Kumar pointed out, nobody is going to take a product which is not really up to scratch. I mean, we have to be competitive in our design, so we design the best possible products for the world as well alongside. So this is something that neither will Indian companies take it. There's no need or there is no requirement for Indian consumers to take something which is not first rate in the world, and there is really no reason why we should not be competitive globally. I think we should start with that intention, very clear intention, that we are going to establish something which is internationally competitive for all times to come, and that intellectual property will be Indian. I think that is the goal with which we need to step forward, and Again, I think this is, in that sense, a very significant day, coming as it does on the eve of the Semicon 2 conference starting tomorrow, which the Prime Minister would be inaugurating, and where we expect that the participation is twice of what it was last year. Many of you would recall that that in itself was a very seminal event, and now coming into India every year and growing at a very rapid rate shows the kind of interest that there is in India. And if companies are coming into India, they are coming primarily for two reasons. They are coming for the talent, and they are coming for the markets. And this is something we need to leverage to make sure that we truly have semiconductor product designs which are made in India, which are designed in India, which have Indian IP and will spread all over the world, and make sure that we have a mechanism by which, as was pointed out, we have our own approach. And I think that is important. We don't have to necessarily ape every approach that has been made in the which has been taken in the past. We may not actually be able to do it, but we need to do it in a way that we do it in our own way. I recall, a conversation about 4 or 5 years ago with Dr. Arvind Subramaniam, former chief economic advisor. So he was telling me, how will you ever compete? And unless you're able to have a factory which employs about 200,000 people like China, how will you be ever able to compete in an industrializing fashion? I said, we may not be able to actually have a factory with 200,000 workers, because even achieving a level of 30 and 40,000 workers is a significant step up from where we were previously. Traditional industrialists in India are not comfortable with having more than 3,000 or 4,000 workers in a factory. And there are a number of other social factors in the way you'd house workers and the way that they would get to a place. But I think we can do something which is different, and a structure which is different. For various socioeconomic reasons which obtain in our country compared to what happens in China. And they could, and we can, and we should try and find a way, in some of the thoughts that Dr. Kumar also expressed, to find our own way of getting this done. And I think we can be internationally competitive through our own Indian genius, through our own way of actually making it happen. And today would be a signal day when we would start doing it. Let me once again invite you all to the Semicon events tomorrow and the next 2 days after that. And I'm sure we'll be seeing a lot of each other over this week. Thank you very much.
Thank you so much, Shri Krishnan ji, for taking your time out during this busy schedule for addressing this August gathering. Next, we have Dr. R.S. Sharma to present his visionary keynote address.
I think the visionary keynote address has been given both by Dr. Sandeep Kumar and by Mr. Krishnan. I think Sandeep Kumar has told us as to how to go about the whole journey, and Mr. Krishnan has laid out the entire ecosystem approach and the Government of India's sort of the things which are being done by Government of India to promote this entire exercise. I will because I am not an expert in this particular area. We have been sort of talking in general about the electronics manufacturing, and when I was in the Department of Electronics and IT, and when we launched the Digital India program in 2014, at that time electronics manufacturing was one of the key areas, and we were talking about doing 400 billion worth of electronics manufacturing at that time. That was the vision. And at that time also, as Mr. Krishnan was saying, we tried establishment of fab, and virtually finalized 2 players, and somehow it did not happen. And then of course Mr. Krishnan today told that this story goes much longer, in 60s and 70s and stuff like that. So I think it's a great moment for this country to really have crossed that hump and really get into the real action. It's an honor for me to join you today at the Semiconductor Product Design Leadership Forum. This gathering brings together leaders from technology, industry, academia, and policy, and it's a privilege for me to be here with such an audience. At the outset, I must also commend Pankaj and ICEA for this timely initiative. India's semiconductor journey is at an inflection point. We have made bold strides in building manufacturing capacity, but manufacturing alone is not enough. Without design, innovation, and intellectual property, we risk being just participants in the value chain rather than leaders. Manufacturing gives us scale, design gives us intelligence. Scale without intelligence cannot lead to leadership. But when we combine both, India can not only make chips, but also shape the future of semiconductors. The government of India has acted decisively. Strong incentive framework supports fabs, display fabs, compound semiconductors, as well as ATMP and OSAT facilities, assembly, testing, marketing and packaging, and outsourced semiconductor assembly and test. These are the final steps that make chips usable. Investing in them shows that India is building across the entire value chain, not just at the front end. Equally important is the design-linked incentive scheme. It provides direct support to startups and innovators working on chip design for future applications. This reflects a clear understanding that we must build capacity to produce and also to have the intellectual strength to design. If I may add a personal perspective, in my career, I've been fortunate to lead national digital transformations such as Aadhaar, CoWIN, and the National Digital Health Mission. These were not just technology projects, but platforms serving over 1 billion people. The Digital India program, launched in 2015, when I was the secretary at DITI, now it's called MeitY, set out to transform India into a digitally empowered society and a knowledge economy. Today, Aadhaar, UPI, telecom infrastructure, JAM, financial inclusion, and digital public infrastructure across health and commerce are all outcomes of the same vision of Digital India. When Aadhaar began, many doubted whether a single secure identity system could work in a country of our size and diversity. But with good design, open, scalable, and interoperable, we created a platform that became the foundation for financial inclusion and service delivery. The lesson is clear. Design is not a luxury, it is the foundation of transformation. Semiconductors and product design will play a similar role in the next phase of India's growth. Just as digital public infrastructure enabled inclusion in finance and governance, semiconductors and design will drive economic competitiveness, digital sovereignty, and technological leadership. But we must face some realities. India's spending on research and development remains low compared to the global benchmarks. Private sector investment is modest. If we want leadership in semiconductors, this must change. Innovation should not be seen as risky, but as essential. Failures must be accepted as part of the learning process. The countries leading semiconductors today, the United States, Taiwan, Korea, and Japan, all built deep R&D ecosystems linking universities, startups, and industry. India must do the same. Dr. Sandeep Kumar brought out that point very effectively as to how the approaches, different approaches, nevertheless leading to the same conclusion, were adopted in Japan, Chile, and China. Shared infrastructure will be the key. The National Electronic Design Automation, that is EDA grid, provides access to advanced chip design tools, multi-project wafers, shuttles, where multiple designs are fabricated together like a carpool for chips, lower costs and timelines. These platforms democratize innovation. We must scale them aggressively. India is one of the fastest growing electronics manufacturing destinations. I think we are hugely now exporting a number of electronic products, the mobile phones being at the top, giving us a scale. But the scale must translate into innovation. Encouragingly, more than half of patent filing now come from Indian residents, a remarkable shift from a decade ago. Yet we must accelerate further. Our focus should be on building strong intellectual property in areas like system on chips, power devices, and advanced packaging, strategically critical for our independence and global competitiveness. Incentives like the Product Design Linked Incentive, PDLI, and DLI schemes can help bridge the gap from lab to market. Friends, we must also recognize the geopolitical context. It is the best of times, it is the worst of times, in some sense. The semiconductors are no longer just about economies, they are about national security and global influence. Nations that lead in semiconductors will lead in technology, in security, and in shaping the global economy. Trust has become as important as cost in global supply chains. The world is searching for reliable partners. With our democratic values, skilled talent pool, and entrepreneurial energy, India is well positioned to be the trusted partner. This is India's moment. Let's seize it. So what we must do, we must support our designers, startups, and corporates. We must provide risk capital, easy access to infrastructure, and encourage collaboration among governments, industry, and academia. Ideas must move quickly from concept to prototype and from prototype to production. Policy support is necessary, but it is not enough. We need entrepreneurial drive, global ambition, and a shift in the mindset from being content as part of the chain to aspire to lead it. If bold policies must meet entrepreneurial energy, India will not just be a hub of manufacturing, but a powerhouse of innovation. Let me close with this thought. India's next growth story will be powered by innovation. Just as digital public infrastructure transformed the service delivery for 1 billion people, our semiconductor journey must be rooted in openness, interoperability, and innovation. This is not about chasing production numbers. It's about building real chips, robust processes, and globally recognized intellectual property. That is how India will secure its place. Not on the margins, but at the center of the global semiconductor ecosystem. India has shown during the last 10-15 years that if it sets out to do something, it need not look at the West or the examples. It can actually charter its own path. That is what we have done in the areas of digital public infrastructure. Everybody said that these things are just impossible. But India created a very scalable, speedy, robust, interoperable ecosystem of DPIs that today the world is recognizing the DPIs created by India. Similar stuff can be done by us, I have no doubt, with the talent, with the entrepreneurial spirit and with the government support. I think we can build that ecosystem which is required for us to go ahead. Thank you very much.
Thank you so much, Dr. Sharma, for that instructive address. As a token of our appreciation and gratitude for your invaluable contributions to our distinguished speakers here, we would now like to present our mementos. I would respectfully request Dr. Sandeep Kumar to present a memento of gratitude to Shri S. Krishnan ji. Thank you so much, sir, for taking the time out to engage with the industry here. I would also like to request Shri Pankaj Mohindroo ji to facilitate Dr. R.S. Sharma for his valuable address. May I request all our guests to please come forward for a group photograph together. Thank you so much, gentlemen. Now we are transitioning to the next phase of this event. We now have a panel discussion for you all. Having explored the different perspectives, we are now converging on a more collaborative platform. I'm again reminded of Arthur C. Clarke, and he formulated 3 laws on technology development. I had mentioned one of them earlier today. Now, the other 2 laws are equally fascinating and thought-provoking. One is when a distinguished but an elderly scientist states that something is possible, he is almost certainly right. But when he states that something is impossible, he is very probably wrong. And second, he says, the one way of discovering the limits of what is possible is to venture a little way past them into the impossible. And that's what we want to do today with the panel discussion. Much like big Bollywood movies, we today have an ensemble of distinguished speakers coming here who have graciously taken out time to share their insights with us. The topic we have today is enabling Indian champions, steering semiconductor product design growth at an intersection of design, policy, and innovation. Moderating this panel today, we have Mr. Sujay Shetty, Managing Director, PwC India. Mr. Shetty leads PwC India's Electronics and Semiconductor vertical and is also a part of PwC's Global Center of Excellence for Semiconductor based in South Korea. With over 16 years of diverse experience ranging from economic planning, infrastructure, policy, and investment strategy for the ESDM and semiconductor value chain. Sir, please come to the stage. Let me now introduce our esteemed panelists, each a titan in their area of expertise, who will join us on stage. First, we have Dr. Sandeep Kumar, CEO, L&T Semiconductor Technologies, also joining us for this panel discussion. Dr. Sandeep? Thank you. Next, we are delighted to have Mr. Utpal Shah, Senior Vice President, Strategy and Business Development, Tata Electronics. Mr. Shah leads Strategy, Business Development and Foundry at Tata. Before joining Tata Electronics, Mr. Shah worked at Intel for 23 years in various engineering business leadership positions across technology development, product design, high volume manufacturing, and foundry services. During his entire tenure, he collaborated with supplier and partner ecosystem to drive technology innovations and HVM implementation. Thank you, sir, for joining us here. Now, please welcome Dr. Ritesh Jain, Axiro Semiconductor. A product manager at Axiro Semiconductor, Dr. Jain is responsible for the product line of RF power amplifiers and small signal RF components. He also leads the company's R&D and innovation management initiatives and supports technical pre-sales connecting innovation with customer needs. Previously, he led hardware development for E-band backhaul radios at a deep tech startup. Thank you, sir, for joining us. Next, I invite Dr. PNSV Narasimhan, Director, Cyient Semiconductors. At Cyient, Dr. Narasimhan plays a pivotal role in supporting the company's strategic vision. His responsibilities span government relations, corporate governance, ESG, as well as spearheading the development of new infrastructure across the group, including semiconductors. We are also pleased to have with us Mr. Suraj Gajendra, Vice President, Products and Software Solutions, ARM. As VP of Automotive Products, Software and Solutions in the automotive line of business at ARM, Suraj Gajendra leads a comprehensive strategy bringing together ARM's IP products and software ecosystem initiatives, delivering best-in-class solutions to the rapidly growing and complex automotive industry. Lastly, please welcome Mr. Raja Manikam, founder and CEO of IVP Semiconductors. An IIT Kharagpur graduate and veteran in product engineering, factory engineering, and business development, Mr. Manikam worked with semiconductor pioneers and shapers such as Texas Instruments, Fairchild, National Semiconductors, SATS, ChipPak, and UTAC. In 2023, he founded Pawnee Tech Consultants by bringing together a group of semiconductor factory experts with a goal of expanding the semiconductor ecosystem, especially through emerging tech markets like India. In 2024, he founded IVP Semi to localize semiconductor chip production, empower Indian companies to improve product development cycles, and achieve great technological autonomy. We thank you all for being here with us. And now, Sujay sir, the stage is yours.
Hello. Thanks, Rishabh, for all that. Good morning, everyone, and welcome to this electrifying panel. I'm quite excited about the kicking off this discussion after the masterclass before this from the first panel. We have another masterclass today. Quite excited to kick off this discussion that's all about wiring India's future. Yes, we're talking semiconductors, the unsung heroes of our digital world. Today's theme, enabling Indian champions steering semiconductor product design growth, the intersection of design, policy, and innovation, is our attempt of creating a blueprint that will transform India into a chip powerhouse. With the market poised at about $25 billion by 2030, and the Indian design talent pool about 20% of the global design engineers, I think we've got the circuits. It's all about flipping the switch. And to be able, while Sandeep and the other panel members in the earlier panel clearly laid out that context very well and also the solution, but how to take it a little forward, what we'll do is we have a stellar panel to take you through some of the steps. But what we'll do is, while we have a stellar panel and they've been introduced by the MC very well about the facts that we already know about them, but we will take about 20 seconds each per panel to speak about the quirky fact that we don't know about them or what sparked their semiconductor journey. And then we will take this panel forward. So to start with, Sandeep, the quirky fact that people don't know about you? So many.
Quirky fact. It's on? Okay. So I grew up in Chandigarh, and in 2020 during COVID I said, since I have to work from home, why don't I come to Chandigarh and stay with my parents and take care of them, and then I'll work from Chandigarh. Well, I came here and I was bored to death.
I am glad that your friend spoke to you. Suraj, over to you.
Sure, I don't know how quirky it is, but my journey began with, I think Utpal will know this, when Intel launched Pentium processors in mid-90s and late 90s. I was still in college, but that sparked the whole interest in semiconductors. Later on, did my engineering, went to UK, did my master's, and a group of 4 Indian students, we basically designed, every final year project, we basically designed the best processor the university ever built. So that started the whole journey.
Amazing. I think Pentium helped a lot of us who are all engineers here, but have surely helped you bring you that you're interested. Raja, surprise us.
Yeah, there's a lot of funny things about me, but most of the ECE graduates and all that, right, during my time, they always end up being designers, right? They go to the US, they all become designers. Except me, I was a test engineer. And usually test engineers are at the bottom of the totem pole, right? Nobody recognizes them. Nobody gives a crap about them. And over my career, I moved around, different positions, always in semiconductor. And at some point I noticed that test engineers can never become a CEO of any company. So I said, my career is limited. So in order to become a CEO, I have to start my own company. And that's how I started TestSolve.
Wow, that's a lot of inspiration to the test engineers there. Utpal, let's hear it from you.
So, my story started actually during graduate studies. I was on a hardcore chemical engineering path doing my graduate master's program. And I desperately wanted to do a summer internship somewhere. It was very hard to find. I was in Missouri, Rolla, in the middle of Midwest. And fortunately, there was a company just a few miles from my university campus called Brewer Science. They were a market leader in anti-reflective coating that is used in the photolithography process. So I got an internship there. That was my first exposure to the semiconductor world. Otherwise, I was going on a traditional chemical engineering path. So I got exposed to photolithography, the etching process, the stepper, the tracks, and I just got very fascinated with the pristine nature of how this industry was operating. So a few months later, I started applying after my graduation, and I landed at Intel as my first job. So that's how it started.
And that's another example of industry-academia collaboration to bring you in the semiconductor business. Dr. Narasimhan, I'm sure there are a lot of quirky facts about you, the few of them.
Sujay, if I will disappoint you a little bit, that's intentional. I might be the only person sitting here who did not grow up in the semiconductor industry. But in early 2000, I was part of how the entire carve-out happened of Freescale from Motorola. And 20 years later, I'm part of how the Cyient semiconductor business started to be created from the original design powerhouse that we were. But I have mostly been on the periphery and mostly an enabler.
Brilliant. Dr. Narasimhan, that makes two of us. I also did not grow up in the semiconductor business myself, and that's quite an inspiration for me at least. Ritesh, last but not the least.
So the quirky thing I remember is back in my graduate studies, like all of you have gone through, so a BTech student is exploring what to do next. And I realized while exploring whether I want to go to robotics, embedded, I want to do VLSI, what do I want to do? I realized in VLSI I was scoring the highest marks, so I thought, hey, I'm good at it, so maybe I'll choose this as my career path. So I went ahead, did my master's, did my PhD and all that. After my PhD, I revisited that scorecard and I realized I had read it wrong. It was actually a different subject. But then maybe it was my heart which wanted to go into VLSI, and that's why I read it that way. Thank you.
That was a wrong wiring for the right reasons, though. Thanks, Ritesh. Now, while this is fantastic, we now know that the chip wizards have extraordinary capabilities and a great sense of humor. And we will use some of their knowledge in this panel to delve deeper into how design, policy, innovation, and other ecosystem enablers can come together and sing together to make India's semiconductor powerhouse. So let's get started. What the format of the panel is, while we will have specific questions for each of the panel members, but we will keep it free-flowing. If any of the panel members feel to chip in and add value, you please do so. So let's start with Sandeep, while you laid out the context very well in the earlier panel discussion, but specifically around, if I have to ask you a question, saying, given India's significant role in IP creation, but lack of Indian champions, design champions, what do you think is the primary barriers for the Indian firms transitioning from service-oriented work to creating more competitive products?
I think it's a barrier, but not really a barrier. When you are doing IP and service, somebody else defines the product, and the service company implements the product. When you are a product company, you have to define the product. And that's the knowledge that is missing. So what ends up happening is most of the product definitions and requirements, which are based on market knowledge, customer knowledge, are being done outside, and then the implementation occurs here. So we have to build that know-how, which is why I think, as the systems and industries move here, we should not only be able to build it, we should be able to excel at it, right, and do it differently. So that's on the front-end side. Similar problem, and, Raja has experience in this, but similar problem is there on the back end, which is the Indian service companies are primarily delivering a design, but they're not involved in the manufacturing yield. Even if it is a fabless, they are not the ones working on that supply chain and how to run that supply chain, how to do the product engineering, the testing, the qualification. That's not part of the service. So they figure it out, but they struggle through it. So companies like Solve have done a great job. And so that is the other half that needs to come in. But again, it's doable. It's not some...
Sandeep, I just wanted to add one thing, Sujay. I think, as what Dr. Sandeep said, see, the key aspect is thinking about the system design. So in China, if you look at it, the ramp up of smartphone and automotive industry has played a huge role in actually the semiconductor chip design and chip manufacturing, because that drove the demand, that drove the need for in China designs and stuff like that. So, India, as what I think Dr. Sandeep's presentation earlier about India has that. India has the inbuilt expertise in system design. It's I don't want to call it a barrier, but it's more about moving from utilizing that system design knowledge and expertise and enabling, the right kind of chips that are needed for that is basically going to be the fundamental aspect.
Right. I think anything that Sandeep and again Suraj and everyone. So what do you think, is that enough for establishing strong linkages between the semiconductor design firms and manufacturing ecosystem? Do you think anything else that is required from a design policy innovation perspective?
Lots of things are needed from policy perspective. Like I said, so the technology and IP, people right now, the policies are driven towards incentivizing chip creation for domestic consumption. So smart camera chip, motor chip, etc. But those are not really the high value, high IP that will create a sustainable business in the long term. And then to create something big, you need capital and you need IP. Not every entrepreneur is going to create IP from scratch. So there needs to be this ecosystem of licensing. How do you tap into the IP? And the IP is available, probably a lot of that is outside of India. The Chinese brought all that IP in. They didn't have it either 20 years ago. They created a whole policy on how to create IP and bring it from outside. So that's needed. Financing is needed. And then go to market, and the best go to market example is Israel. They don't have a market, but they create a disproportionately large number of semiconductor startups that are sold off at very high value. And they have figured out how to tap into the global market. And that whole ecosystem is designed that way, right? So Israeli startup ecosystem, the government policies, even the Bird Foundation, the investment mechanisms are designed. So you need, go to market, you need IP, and you need the business and financing. Three elements.
Yeah, I think, what Krishnan was saying was, in terms of manufacturing, right? There's a lot of money that has been put into manufacturing. Now, how is this manufacturing going to help the startups? If I think at it now, I'm a startup guy, right? And I'm an Indian startup. I want to create, products out of India, and I'm looking for the Indian market. I need to have some advantage that these, investments in India is going to help me versus a foreign company coming in. Today, my competition is foreign companies. I'm trying to just replace what the foreign companies are doing with my own products, right? So I need to have some advantage. What is that advantage? Is it from pricing, from access to technology, whatever it is, right? So I think there needs to be a policy which says that, look, we are using taxpayer money, And we are talking about tens and thousands of crores to whether it's Tata or Keynes or CG Power or whoever it is. Who are they targeting? They're targeting the foreign companies because that's where they're going to get the volume. But as the startups in India, that in the next 5 to 10 years, what advantage do I have? Because when I go to Taiwan today, I don't have an advantage, right? In fact, I get pricing which is much higher. So I think, there is a policy that needs to come through which says that, look, for Indian companies, since we funded these guys, right? And we're also funding through DLI and so on, there must be a link which will help us get there. Whether through, access to prototyping at a better cost, timing, performance, whatever it is, right? We'll allow to maybe tweak the process. Maybe when we go to volume, there is a substantial benefit that we get. So these are all some policy changes that, they should start considering.
Thanks, Raja.
Can I comment on? So I think if I draw the parallel to manufacturing, design and manufacturing, in India, we are missing so much of the strength on the manufacturing side. We don't have the ecosystem in India. We don't have the talent in India. We don't have the infrastructure in India. When I look at the design side, we do have the design ecosystem in India. Design ecosystem means companies, EDA companies, IP companies, design services companies. All of them are loud and present in India in large quantities. So we have the design ecosystem. We have the design talent. Like Mr. Sandeep said, 20% of the design concentration of all design engineers is in India. So we have the design talent. We also have the design IP access, infrastructure access. There is DLI that the government has come up with. What we don't have, I do agree with Mr. Sandeep, is the system level solution. And there is one advantage that India has. When you look into system level solution, SoC integration, product definition, product architecture, hardware plus software optimization, India has another strength which is on the software side. All these software firms are actually dealing with the same companies to help them with the software solutions. So what we should do in order to pick on the system design area that India can attack, we should have a very strong collaboration between the software firms and the design firms at the system level. I think that can really be a significant force for India in terms of attacking the system level solutions, is to partner with software companies, design companies, and go after the system level solutions.
Thanks, but I think you can kind of answer my next question also, where Sandeep brought in a point about ecosystem, enabling ecosystem development, and who better than Tata Electronics, who have been able to do that effectively for all greenfield projects and sectors. I think that's a great insight on the ecosystem side. But while the ecosystem, if you can further emphasize on what other ecosystem enablers you can think of, plus what does it open up to? What are the most promising opportunities globally that Indian design semiconductors need to leverage upon? Can you pick those opportunities?
Yeah, so if we think about if somebody wants to start a design company, there are a few things that the company will need. The first thing is they will need an architecture set, whether it's ARM, we have Suraj here from ARM. It could be RISC-V.
It's only ARM.
It could be RISC-V or some other architecture, so you need that. You need the EDA infrastructure. You need these IP portfolio, whether it's foundational IP or interface IP. We, from Tata Electronics standpoint, we have decided to go after the 28 nanometer to 110 nanometer nodes. We are working very closely. We are going to announce the MOU tomorrow with CDAC, where we are partnering with them to make sure that we not only provide the EDA infrastructure to the startups, but also provide access to the hard IP portfolio. These hard IPs like USB, MeitY, DDR, every startup, design startup, SoC startup will need access to this hard IP portfolio, and that is not having an access would be a disadvantage for the Indian startups. So we are working with CDAC to make sure that we generate a portfolio of hard IPs that are already ported on our foundry technology, so that when the startups are designing their SoC, they can leverage these IPs. So these are some of the things that we are doing. There is also another thing that the startups would need, which is prototyping, pre-silicon, post-silicon. This is capital intensive in nature to have simulators, emulators in order to do the prototyping. So from the policy standpoint, that is one thing that we can collectively look into, is how can we provide subsidized access to the startups, not just for the EDA environment and design IP, but also for prototyping, pre-silicon, post-silicon, provide them MPW support. That is another thing that we are doing between Tata Electronics and CDAC, is that we will give multi-wafer product shuttle access to the startups. So they can put their IP on the shuttle, they can get the silicon verified results from that shuttle, and provide them PDK support. Typically for startups, getting a PDK support comes at a cost. Through our partnership with CDAC, we will be providing that PDK support pretty much free of cost. So these are the things that I think startups can benefit from in terms of how to leverage the manufacturing ecosystems, the interface between design and manufacturing.
I think I like the Tata twist to it. I think fabulous, great insights. But building ground up, Ritesh, if I bring in, so while we spoke about the certain ecosystem that needs to be created in India, all that, and to be able to compete in India, but do you, when you are competing globally, do you see any specific challenges that you face while competing globally?
Thank you. Yeah, I think much of it has actually been covered by Sandeep ji, so I would probably end up summarizing some of that. But I see the problems as, 4 sectors, 4 C's that I call. So one would be your capital or cost. Another would be your credibility. Another would be the customer. And another would be the capability. And if I can elaborate on all 4 of these briefly. So on the cost part, I guess we all are from the semiconductor industry, so we know. So the nature of capital is slightly different compared to software. You need to have upfront costs for all the ADA tooling. And of course, I would recognize that the government and other people are doing very great work in this area to make this accessible to everyone. Then you need to have MPW capabilities to actually test your ideas. And this is also capital intensive. And if you don't have something like subsidized runs, then you either end up spending too much time to make sure you are not making a mistake and basically moving out of your market window, or you end up with a mistake, or you don't actually innovate there. And if you don't innovate, then you don't actually get your moat. So that's the capital part of it. And that's what capital needs to understand the nature of this business. Second would be capability. Like Sandeep sir said, most of the entrepreneurs are engineers, and we need to have a product mindset. We need to understand our product market fit, spend time with the customers, understanding their pain point. If we are not able to answer with our product how that product is addressing the customer's pain point, then it is not a product. The story is not really finished. So that's the second part of it, I would say. We do need a product mindset. Third one would be your customer. So one thing I realized working in this industry is that having an anchor customer is very, very important. If you have an anchor customer, not only the customer guides you to what kind of product do they want in their end systems, they also de-risk the whole process. You can have a predictable LTV, predictable revenue line, and you can work very closely with them to develop these products. But startups need to develop these relationships with these anchor customers, or maybe the government need to facilitate so that these anchor customers, maybe the government institutions, can come in and be the anchor customers for one of these chips for the first time. And when these ideas are tested, they can go to a wider market, of course. Last one would be credibility. Because we have not seen successful design firms in India yet, it is a little bit of a chicken and egg problem. How do you establish the credibility? But on that front, there can be some things very simple. Like for example, Indian design firms can be the most transparent ones. We can put out together very nice documentation on how we did design it, how did we qualify it. And I know because I have been on the other side of the table as well, hardware integrators or OEMs really appreciate that, if they have a very, very transparent view. And on the other hand, we all really should advocate Indian Make in India chips. Like, for example, our Indian diaspora all around the world can also advocate using Make in India. Of course, it does not come at a cost of using an inferior product, but still, promoting all of that. Yeah, thank you.
I like your 4C concept and framework. I think PwC will certainly use that in some of the client pitches. I will give you credibility to that. Another 5th C. So Ritesh, while it's quite very well laid out, but we'll say in the earlier conversation or panel, Pankaj and the entire panel actually laid out that there's a large opportunity, given that electronic sector is actually driving the growth of electronics and semiconductor. And there is the lot of pillars that we could use, that we could leverage, such as AI, 5G, automotive. You see any interplay between academic, MNC, startups coming together and some of the solutions solving for some of the challenges that you mentioned?
Sure. So let's first look at what kind of strengths do we have in these pillars. Maybe 5G, automotive, AI, which is coming up. So some of the strengths that we have is, first, we all know we have a very huge domestic market that always comes. That is always good, that you can have a consumption. Second one is that we are good in software and system integration, so we can at least handle that part. And third one is that, of course, these pillars are still developing, so you can actually plug into that development and move to a global sort of product landscape. You can do that. Now, how to leverage that? Basically, we need to understand what niche areas can we focus on. And with niche, I don't mean that you don't add value, but you make products in more focused areas. Like for 5G, you can use RF front ends. For AI, you can only focus on edge AI for the time being. Along with that, because you also have a market window that is quickly sliding and you need to quickly move forward. So reuse everything else that you can. Reuse the IPs, reuse the boards, reuse the design. And eventually, like everyone was saying, move to a system level or a reference design sort of view. That reference design can quickly go into the market and eventually give you that edge, also that credibility to move your product. So in that sense, MNCs, for example, can be the resource which can mentor startups, open up their pool of IPs to be reused in these kind of products. Startups can be the one who actually take the risk. Develop these innovative solutions along these focus areas, or do system level integrations, develop those reference designs. And all that can be anchored with academic R&D support. So the innovation can actually be rooted from the academic R&D support. And that can be a good collaborative pipeline where we can move towards an end product. Thank you.
Great. Thanks, Ritesh. And a lot of emphasis on capability and talent. While we boast about 20% of the world design engineers, and Mr. Sharma and Mr. Pankaj all mentioned that another million jobs are to be added in this business, creating room for 3 to 5% of the GDP. So how, I'll bring in Dr. Narasimhan, your point of view, on how can academia contribute effectively to this design talent pool? And more importantly, how industry can play a role to bridge the gap between education and real life innovation?
Thank you, Sujay. Some of my comments will come from the context of our own experience. We built semiconductor capability for our company over 10 years before we turned a business unit into a company. And we started with a small acquisition that had analog design capabilities in Europe. And it took us 8 years to multiply that 10 times. Even the denominator was very small, 40, 50 people to about 500 people. I'm sure many of you in this room know that this is not like training people on coding. It takes 3, 4, 5 years when you're bringing in this kind of expertise that is required. So I think it's easier to say that we will go and put some investments into the top institutions. We heard this from a policy perspective. That is important. But there is one comment which Mr. Krishnan made that will be very important for us. If you don't expand it beyond the usual suspects, I think this journey is going to be very difficult. And I think the example is, I think we also have some very great talent coming in from the Indian organizations that we don't refer to, right? Some of the parts of MeitY, CDAC, we have some experts sitting here from there, ISRO, DRDO agencies. None of those engineers have come from the usual suspect routes. Okay? So I think it's important for us to be able to build this. Our own experience of building about 13 centers globally and being able to bring that to India now is telling a slightly different story from what many of my co-panelists have been referring to. It's not going to be isolated from an India out kind of an expertise or an India in, as Ritesh just mentioned, saying it's not going to be easy asking any MNCs to say, help us incubate, because you're going to be having a conversation beyond 5 minutes will stop if there is no payment for an IP. Right. Okay. So I think I will leave it at that, so that we have to be very real as we are navigating these issues. So the second thing that I would also mention is test engineering, and Mr. Rajamanikam just mentioned with his background. I found that very interesting. Today you will find engineering colleges kind of putting so many suffixes on the ECE specializations that it is mind-boggling, but you won't find test engineering anywhere. Okay? Much of it is left to organizations where they are investing into their own internal training to bring that up. Okay? So the industry, institution, or the academia conversation has to be a little more grounded, has to be multi-pronged in a way, because we are not going to be able to build that capability at the speed at which we want. Okay, you can put in a policy measure, you can possibly put in that multi-billion-dollar fund that Sandeep ji was talking about, relatively more easily than trying to build this talent that we want if we have to meet that 2030 milestone. Okay? And one example, or maybe two suggestions that I have for it. One is, let's get a lot of people from the academia to be immersed into what the industry problem is, whether it is an uncooled camera chip that we are working on, which we keep hearing that as a priority, and not stop with just writing research papers. Okay? As much as I will be sounding a very harsh tone here, a lot of research grant is ending up in research papers. It has to go beyond that if we have to be serious about what we are talking here. So those are two areas, trying to bring in test engineering as a domain expertise at the undergraduate level, so it becomes industry ready. And the second is bring in an immersion from the academia into the industry, from industry into the academia as quickly as possible, are two things that I would suggest, Sajay.
Just to add to that, Sajay, I think just wanted to highlight and stress the point about immersing students into the system, right? Because the rate at which the technology and innovation is happening especially after in the AI era is unbelievable. Every sector, right? Be it smartphones or edge AI or automotive or any space. So I feel that when I talk to my own cousins, forget about who are actually in engineering and masters, they are not there. They're not learning the most latest stuff, right? They do probably 3 months internship, 6 months internship, but even then they're not exposed to the right technologies, and they're not actually made ready when they come out from the academic institution. So it's super critical to ensure that kids, especially undergrad and graduates, are exposed to the right technology and innovation that's actually happening today, and not something that happened 10 years ago. That's one thing. And one more key point is my son, who's basically 11th standard, he did a high school internship in US this summer. So the people already kind of like in the US are looking at exposure into industry, how does all the aspects really work at very, very early stage, like high school. So again, it's not rocket science. I mean, he didn't go and learn like chip design, but he just understood how finance, corporate marketing, engineering, all of these aspects basically work. And especially today in the AI world, how these companies are actually using AI tools to actually get their work done, and what it actually means for someone like him who's going to come out into the industry about 6-7 years from now, needs to sort of anticipate, right? So it's unbelievably important for that kids to understand where things are, what is happening, and get ready in order to reach there.
So I just wanted to add one more comment about the research paper things Sir just mentioned. So what I feel in academia, a lot of incentives are aligned towards the research papers. And that's why, people end up with those kind of research papers, be it promotion, be it, faculty hiring and all that, be it grant funding, some of that is inclined towards, how many publications would you make. So I believe some of that alignment also needs to be changed to get out of that mindset and do more applied research rather than, theoretical research. And the applied research will also enable students to think more about the customer and the product. Of course, thinking about equations, circuits is also important, but like we are all agreeing here, that mindset is also very, very important today. Thank you.
Great point. I think there's a lot of understanding and the learning from other geographies. But yeah, Raja, please.
I just wanted to add there. See, how many of us, right, from the industry actually approach the academic institutions and say, look, I want to do this, or I want to sponsor this, or take some of that into the industry. I think the industry has to make the move. I mean, it's no point, because academics are what they are, right? They're supposed to be doing deep research and so forth. So I think, our industries don't interact as much, right? And they don't do R&D. I mean, let's all be, frank about this, right? I mean, most of our companies don't do R&D. We're just great followers. We like to do service for other people. We just don't want to do it. And this is where I think, there needs to be a cultural change in attitude. I think government has already done a great job. They put in a lot of money into all of these things. But the private sector needs to, step up. And not every initiative has to be ROI and IRR and so on. Because a lot of these, semiconductor initiatives will not meet those criteria. So some of us in the industry have to really step up and say, look, let me adopt this startup, for example, right? And you bring, as an industry, you'll bring a lot of, experience, go to market and so on. And the startup guys being engineers, right, they're pretty good at what they do, but probably don't have that wisdom to go all the way to make a product. So one of my thoughts is, that I want to leave with this audience is, I have this thought about adopt a startup, right? If you are 1,000 crore turnover company, right, put maybe 10 crores a year, just to do this, and some may work, some may not work. But I think this is how, the community will get involved in the startups. Because I can see there are a lot of startups. I mean, a lot of startups are struggling, right? I'm working with one of them that is about to shut down, right? Great guys. And they don't need that much money. They need about 1 crore, and we couldn't find 1 crore in this system. That's a sad part of it, and we sit here and, we can talk about, all the skilling and all of those things. I think there are a lot of people already engaged. They need already support. And this is why I think we need to have a cultural change in mindset with the people who've got the money, who have been, making a lot of the money. I always talk about NASSCOM, right? A lot of NASSCOM are service companies which have generated a lot of cash. I know I would encourage that NASSCOMs, adopt maybe 10 startups. They have the money to do it. And these guys can, build that, because they also bring a lot of experience from a go-to-market strategy.
Great point. I think I'll take that point, Raja. We're not doing enough innovation, R&D. We've not been able to contribute to the R&D. We're not spending enough. That's a point that I will take and bring in Suraj there. Suraj, how will we solve this? I know that innovation-driven entrepreneurship actually is quite established elsewhere, and it's an example that it develops robust semiconductor design ecosystem. So what are the key examples that you see, and what frameworks do you see from an example globally that we could bring it to India and India can adopt it?
Yeah, so just to continue on what Raja said, I mean, it's super critical for us to think about it as what the industry can do, right? I mean, how can we sort of drive the innovation, ensure that the whole community is actually coming along with us? So I think that, I mean, there are many frameworks, I mean, but I think it's fundamental that we play a part in this.
Absolutely. So, but any specific tools that you can mention? See, we want to hear high-end SoCs being developed and being applied on HPCs, high-powered computing, AIs, etc. Any specific tools that you think are relevant for this market that we should actually recommend and we can bring into the startups for developing those tools and getting access to?
You're talking about design tools or?
Design tools, yeah.
Well, I think design tools, pretty much dominated by those few companies, right? American companies and all that. And I think, through CDAC and other programs, right? The chip to seed or something, right? Chip to startup, right? So I think they're doing a pretty decent job on all of those kind of things, right? I think those are very, very innovative ideas, right? To get them to almost at zero cost. I think where they need a lot more help is, really the industry partner to work with them, right? So you got an investment partner, and the investment partner is always looking at ROI and IRR and all that, right? But I think, a lot of them, right? I mean, you take NVIDIA, for example, right? I think NVIDIA would not, Jensen will tell you, there were 3 times, the history of NVIDIA that they would have gone bankrupt, right? If they had used ROI and IRR, NVIDIA would not exist today. My company, Tessolve, when I started, right, I went to the market and asked for money. And the guys who were doing due diligence, for Hero to buy, were the guys that said, no, they will never fund Tessolve when I first started. And I can say that, a week ago, they came out that same guys bought the company at a valuation of $500+ million. These are the same guys who would never have invested when I started. So I think, my point is this, right? That the ROI and IRR and all that will not work. And this is where some of the risk decisions need to be taken, and in the industry needs to get involved. The government can only do so much, right? Because they are not very good at taking them, helping them to go to market and so on. I think this is where, the industry can help.
Absolutely. Yeah, just to add one more thing, Sujay. I think, again, the key aspect, and you talked about the framework, the key aspect is reducing the entry barrier, right, for all of these startups and companies. Again, for example, we are a global company supplying IPs to literally, every industry. And we've initiated a program called AFA, Arm Flexible Access, which is a framework mainly to drive more and more companies to basically adopt and build chips based on our IPs without any licensing cost. Now, that's one framework that we want to basically sort of have front and center. Again, the IPs that we actually have in the ARM Flexible Access is not just low-end microcontroller class IPs. We actually have our Cortex-A CPUs, which are high-end application CPUs and stuff like that. So all of us have to think about frameworks like that can reduce the entry barrier as much as possible. At the same time, make it much more easy for the new companies and the ecosystem to grow, right? Another key aspect, again, another framework that I can think of primarily from ARM's perspective is the software ecosystem, right? So we all talk about, okay, chip design doesn't end at chip, right? I mean, you also have to think about solution. You have to think about the workloads that the chip is actually going to be enabling. So it's absolutely important for everybody and players in this ecosystem to think about how do we ensure that when the chip comes out of the manufacturing, it gets enabled seamlessly, right? We can't end up having multiple steppings of the silicon and stuff like that. So you have to ensure that you design to a core software ecosystem that is tried and tested, right? So again, all of those aspects are pretty key.
Quite wizardly insights indeed. Yeah, please.
So I think from the innovation standpoint, the first thing we have to decide is what markets to go after, right? And we did a similar study when we launched into the manufacturing business. And I think a similar approach can be taken on the design side as to, what markets to go after. Now, if you look at India, the semiconductor consumption of the total TAM is currently sitting at 5-6%. It is projected to go to 10% of the total TAM and by 2030. And if you project it out to 2040, it probably will reach 20% of the total TAM. Now, if you think about where is this local domestic consumption of semiconductors coming from, which, what are the markets? What we have come to know through the analysis that we have done, and I'm sure Pankaj, ICEA must have done similar analysis, is that this growth is really happening in the what we call planar nodes, which is what we are going after, 28 nanometer, 210 nanometer. And within the planar nodes, there are markets like power management ICs. If you again look at India, India is the fastest adopter of the electric vehicles, both four-wheelers and two-wheelers. And beyond EV market, there are other markets in India where the PMIC, power management ICs, is going to be exploding in usage. So how can we focus on that market from the design standpoint and have companies that will, because even in the PMIC chip, there is a lot of innovation required in terms of reducing the power usage, low power chips. Another area is the gadgets, electronic gadgets that are on a significant rise. All of these gadgets use displays. So display chip, or DDIC as we call them, is another area where innovation can happen. There is going to be probably a display fab in the country as well. So we will have an ecosystem to support the startup from the manufacturing standpoint as well. Display is another area where the country can focus on. The third area is automotive, right? In automotive, again, significant consumption of automotive, and there we have. I think Sandeep sir was talking about, today the electronic content in the bill of materials for automotive is roughly between 4 to 6%. It's projected to go to 20% by the end of this decade. 20% of and that combined with the fact that the number of automotives are growing. So that again creates a very large market for automotive MCUs or central processing units. So these are markets. Also, these areas are, I would call them low complexity from the chip design standpoint. It's not like you're targeting a server or an AI chip where it becomes very complex and requires $300 million of funding, 5 years to get to a finish line. These products you can invest 10, 20, $30 million, have a 50 people team and get to a finish line within a span of 2 to 3 to 4 years. So these are the areas I would say from the market standpoint where the innovation can focus on, and it's probably the fastest way for India to have product companies.
Any other points, Ritesh, Narasimhan, to add to that?
No, you wait, sir. I don't have any.
You mentioning about automotive, I think medical devices would be another area, right? Because the kind of applications that are required for this country could drive that part of innovation so much.
Absolutely. Those are, I think, great insights. What we'll do is now I would ask the panel 2 key steps that are required, top 2 key steps each, that are required to create 50 most promising startups in the semiconductor design space. What 2 actions would you take?
I think, as I mentioned, I think the private sector needs to step up. So far, all the initiatives has been from the government sector, giving out incentives and grants and things like that. But we don't see the private sector stepping up and supporting in a big way, right? So I think they need to. Like I mentioned, the other thing is, even if there is money, right? I think adopting, right? If the good industries that have got a lot of experience, if they can adopt 1 or 2 startups like that, right? So I think that will be very, very critical for them. When I say adopt, right? You spend some time with them, on their go-to-market strategy, maybe put some money in there. Don't look at so much about ROI and IRR, but then, and these are companies that require, 1 crore, 2 crores to just get them over the hump. So I think those are all, little things that can be done to make them successful.
Sure. From my side, 2 things. One is reduce the entry barrier again, okay? Because for any industry to thrive, we have to make it easy for the industry to thrive, and that again, when I say it's not just a policy thing, it's also as what Raja said, it's also about us. It's also about us trying to sort of not think profitability all the time and ensure that there are programs within our business models that will allow much more affordable rates for startups to get started and create an ecosystem. So that's one thing. The second thing, again, for the companies themselves, it's more about thinking solution, thinking, as what Dr. Sandeep said in his keynote. If you want to build a leading edge chip, you have to, if you want to compete, you have to build a leading edge chip. And if you have to build a leading edge chip, you have to think solution. You have to think about, the workloads that it needs to enable. You need to think about what's the ecosystem it needs to play. So a solution level thinking is absolutely critical for anybody who is entering this, product space.
I think I'm going to repeat, but in a different way. The first step is we have to, part 1 of first step is pick an industry. So let's say we are going to do something for automotive or medical. Part 2 of first step is bring the companies in that industry together and put on the table the top 20 problems they are having. What is it they would like to get solved? My problem is, too much power consumption, too much latency, whatever it is. Then you bring in the researchers and IP companies and say, what IPs you have? And then you bring in the entrepreneurs and say, okay, this is the problem, this is the IP. And create a platform which that IP is available to them, go solve this problem. Can you solve this problem using the IPs? And if you can't, then you have to either bring in more IP into that portfolio, some technology, you have to go to another outside, wherever you bring it. And once that problem is solved, or at least an idea is on the table, then you finance that idea, make sure the industry commits to buying that solution. And okay, 5 people have to solve it. There will be 5 POCs. They evaluate. One of them is best performing, and that becomes a real company. Then you put the team around it and create that. So that's the kind of, maybe more than 2 steps. I'm sorry.
Yeah, no, absolutely. I can hear you for day long, but your 2 points, Utpal.
Yeah, I think first of all, I would like to say that the government of India through ISM and MeitY have created decent policies. There is DLI, there is also RDI they came up with, which is a 1 lakh CR policy for research, development and innovation. There is also DLI 2.0 in the making from ISM 2.0. So there is plenty of focus on the design area. Collectively as an industry, we should figure out how to leverage the RDI because it's a large pool of money, right? Startups can definitely leverage that. The second thing I would say is that there are certain segments beyond the ones that I spoke about earlier where Make in India can be made as a policy. For example, smart cards that we are using like Aadhaar cards, PAN card, these are very sensitive cards. There should be, the chips that go into those cards should be secure chips. They should be mandated to be made in India. Navigation chips that are going to be used in the massive infrastructure that we are creating across India, again, very sensitive. They should be mandated to be made in India. Smart metering, energy smart metering, area, which is again growing very rapidly across the country. We should have a homegrown chip in this network of smart meters, because again, it's a sensitive area. We don't want the country's energy infrastructure to be shut down through some hacks. So these are some areas where government can maybe look into, along with, in collaboration with industry, to have made in India chips. That will give the motivation to the local startups to look into those areas and develop some solutions. There are already some startups looking into these areas. And then the last thing is reducing the entry to barrier. You know, how do we make the playing field on an equal footing for the startups in India as they are competing with international startups or international large companies? There we need to really make sure that access to things like EDA, design IPs, prototyping capabilities through simulation and emulation, MPW support, PDK support, all of these things, maybe we can put all of these things together into an accelerator that was talked about earlier. That's a fantastic idea, because if you have an accelerator where you provide these 5 things, EDA, design IP, prototyping capability, MPW support, and PDK support, then startups can just focus on their core innovation. They don't have to worry about all these other things. They're not bogged down by the burden of capital or investment. They can just focus on the main innovation, the core idea that they have.
Thanks, Utpal. Over to you, Dr. Nazamin.
I will add to what Utpalji just said. I think there is, see, while we are talking about startups, I think we'll have to conflate the issue to a much more broader playing field. I think the reason why we are also sitting here is we are seeing a very different momentum coming in from the government. So the emphasizing on the giving some kind of a preference to the IP coming in from India into the government or government-related projects, I think will be very, very useful. If not kind of establishing a quota, I think giving a higher weightage will certainly accelerate the kind of innovation that that can be seen. But corresponding to that is also the kind of investments. While I agree with Mr. Raja on what he said, that's applicable for startups, but even large players or aspirational large players will need money. Any kind of a product or a solution development will take at least 3 years, right? I think many of you will know how difficult that is. And if you're a listed entity, you will have other pressures. And having some kind of a funding arrangement will be very, very useful. It will kind of put the octane into what is going on currently now. But I will also say that some of you gave the example of China, and Sandeep ji talked about how the whole thing happened over the last 20 years. It will be important for us to get the kind of expertise that is available outside, and to be able to make the problems that are currently opportunities for us, to be able to attract those people to come and work on those projects. It will be amazing to try and get some of those people to do their tapeouts here. I think all these 3 points, the ones what I would say, 2 that Utpalji has already mentioned, and the third one on getting the global talent available here. We are doing that as a company, but I think it will have to be done at an industry level.
So I think there's a perception on the government-related IP that these come in low volumes. And in fact, actually, we did an assessment on this, and these government-related chips, they can actually fill up the entire fab. There is so much demand in India across this infrastructure that it can fill up an entire fab of 50,000 wafer starts per month. So.
Thank you. Over to you, Ritesh.
Thank you. So most of the ideas have actually been, explained by all the panel members. So I may end up repeating, but top 2 things for me would be: one, you pick a focus area, like Sandeep sir was saying, and develop those micro ecosystems around that focus area. Bring in all the stakeholders. Maybe it can be an accelerator. It can be all the supply chain partners, other companies, and all that. So that would be one thing to really make a very focused, good move towards productization. And second thing, like everyone has been saying, lowering the barrier to entries. This may involve looking into more frameworks to have a wider bouquet of IPs or a wider bouquet of process technologies. Of course, in a realistic manner, like sir was saying, because of course everyone needs to get some kind of ROI on their value. Without that, it becomes a little bit, unrealistic, at least, going in a longer period, and we need to have something which is very, very sustainable. So I think those two things, if we can solve, then those are the top two things, in my opinion, which can lead to. Good point.
Thanks, Ritesh. I think those are great insights, and we have a lot of action points and the action plan for enabling Indian champions. I think we are at the top of the hour. Before Rishabh comes and hints at me, we are top of the hour. We would have missed certain points. Are there any questions from the audience that we can take up? Maybe one or two questions.
Hi, this is Anand from Calico Technologies. I just wanted a question about post-silicon debug in terms of low voltage probers and semiconductor testers that are actually required for debugging of silicon. I'm not too sure if any of the things that are happening today, are they addressing some of these things? And because it also actually requires a lot of specialized capabilities to handle these equipments and things like that. It's not just producing these chips, it's actually being able to debug. And many times with the design teams being around, and these are the kind of things that have to be looked at. I know actually I was in Intel in Bangalore, and we created one of the biggest testing capability center in India. Probably something like a few millions of dollars for a given square footage, and it requires the floors which are actually completely vibration free, and because when you're doing some low voltage probing, it has to be so accurate that even micro level of movements of anything actually cannot be tolerated. So I hope there's some discussion, or maybe these kind of setups actually being put together. Maybe Raja might be able to answer this.
Yeah. This is part of the things that I do. I think with what we are doing, at least what I know is from Tamil Nadu government and IIT Madras, we're putting together a center of excellence for packaging and test and all that, right? And targeting exactly what you said, right? Because individually companies will not be able to buy this equipment and then even operate them. The utilization also will be very low, right? So we're using these kind of reach out programs that are industry requirements, that the government and the institutions are together, developing those kind of centers, right? And hopefully if this is successful, there will be going to be more and more of this around. But one difference will be that it'll be run as a PPP model, right? Public-private partnership, where because if you expect the government, related companies to maintain it, that's where they run out of steam, right? So we're encouraging industries to take over these centers and run it so that from an operating expense and all that, it's covered, and they also keep up with technology. But I think government has recognized this. I think, and especially Krishnan, I have a lot of meetings with him on this, because the equipment is very expensive. How to use the equipment, that kind of talent is also, most of it is an art, right? So it takes time. So I think they're addressing it.
I think debug and characterization also some of these things, which particularly when you're talking about a new fab, characterization becomes a very important aspect, and so those are the things that we looked at actually.
Yeah, Raja, correct me if I'm wrong. I think from a talent perspective, again, I ran a test and validation team in India, at Intel India in Bangalore 15 years ago. I still remember we go into Penang, Malaysia for all sorts of power-ons and everything, and now even a lot of tester debug, tester validation, all that stuff happens in India. The talent part of it, I believe, is sort of not that big a problem these days in India. Is that correct? I mean, equipment I understand, and manufacturing equipment is a totally different ball game. But I believe we do have that talent in India now. Is that correct?
Thank you.
I think I want to say two things, responding to Utpal and also Sandeep's earlier point. See, everything is on the table now, right? What events, what has happened. So, whether it is weaponizing your market access, right? It's very clear. You would have seen on 15th August the determination. Very clear that everything is on the table. Now, that Sandeep's point was that we have to be of global quality, right? We cannot create a protected market access and produce ambassadors and Fiats. And this is, I'm quoting the most senior people in the country. Their big concern is that we don't want to be in the ambassador era, but we have to be global. But when it comes to weaponizing market access, making it policy driven with sufficient quality and competition, that there is absolutely the greatest determination today. That I want to assure everybody. So anything, please, any points, please reach out to us. You can WhatsApp me. I'll just circulate my number also. I think most of you have my number. So we are completely determined that we have to make it happen. That is that first the headroom has to be created, that everything which is being imported will start getting assembled, and the foundational industries we are talking about now, but the ECMS is hugely successful, so the middle which was missing is also coming. So IT, hardware, consumer electronics, we brought in very senior evangelists now. I'll just request Rakesh Srivastav to stand up. Rakesh is chief evangelist for auto. He was MD of Nissan, so he has decided to put in his best for nation building. Salil Kapoor is the chief evangelist for air conditioning, appliances, and consumer electronics. Salil is 3.5 decades of deep experience in that. So this is what we are trying to do, that manufacturing also moves, because we have $500 billion to worry about, which is just 5 years. And this whole thing that, in the core we have to be policy driven and see that we are able to back up our entrepreneurs. But I think Sandeep's central point is that the global access of those, what we produce and what we design, will be absolutely critical for our credibility.
Thanks, Pankaj. Any other questions? We'll ask one or two questions. Yeah, please.
Hello all. I am from Primesoft Technologies, CEO of the company. So we are into the IP business. At least I have overall 25 plus years of experience in the semiconductor field. So before, in my career, my managers or the seniors used to say, if I invest the same amount of money in the services, I would have got a better revenue. So at that time, there was a little scope for the IP development to be done. But now I think the scenario has changed. Government has a lot of initiatives. And even right now, the more of the preferences goes to the products getting developed. And I feel the IPs are the backbone or the skeletons of the products. So for developing the IP and to make the IP companies to be sustainable and alive, there should be more government initiatives and government funding, or the encouragements from the government side should be done. This is my request. Thank you.
I mean, I 200% agree. I have a story to tell you about ARM. I used to run the TI microcontroller group. And we had our own 8-bit and 16-bit instruction set, which we developed in-house. And then Nokia decided to make a cell phone. and Tavis decided to make a ABS system, both of which needed a 32-bit micro. And we did not have one in-house, and it took too much effort. All my resources were busy. ARM was 17 people company, and we put 40 people there from my team to make ARM7 TDMI, the first core of ARM. So IP can be a big, big, big business if it is done the correct way. And it can be a foundational business. I mean, when you sit here, you say, well, I want to do ARM. When somebody says RISC, you say, no, it's only ARM, right? So that's how big it can be. So yes.
Can I add to that? Actually, I appreciate this, right? You know, I'm one of those guys who feel that we are too much into, you know, creating IPs and all that. I mean, we give a lot of, instead of products, right? So I think, you know, the business model where, you know, the IP and the product company, they share from a business financial model where, you know, you get rewarded, right? Kind of like this ARM model, but ARM is the only successful IP company that I know of, right? Despite so many IP companies being around, right? So there is a challenge for, you know, pure IP companies. A lot of IP companies in India actually sell the IPs to whether it's Korea or Japan or whoever who make the product, and they make 10 times, 20 times more, right? I mean, I guess that's a problem, right? Where, you know, the IP companies don't get the real benefit. Like you said, they are the backbone, right? So you know, the world is not fair. But I think, you know, in the context of India, we can, you know, I think somebody said, you know, Krishnan also said that we don't have to follow the Western model that started, you know, 30, 40, 50 years ago. We have a clean slate to go, right? So how do we collaborate with the IP guys? So for example, right, my company IVP, I'm not focused on creating IP because there are many, many companies which will do IP. I'm more interested in creating the product and taking it to market. But how do I work with these IP companies, right? Do they take shares in my company? You know, or do I give them shares? Do I give them money? How do I share? Those kind of things. I think it's a business model that needs to get evolved.
Thank you. Maybe one last question.
My name is Tata Narsingarao. I'm former director of a materials research center at IIT Hyderabad, and after my retirement, I moved to IIT Hyderabad. I'm representing director of IIT Hyderabad today, Sandeep ji. So, being a material chemist, I'm not a chip or semiconductor specialist, but from materials perspective, what I see today is all the chips what we talk are silicon based, right? So, and I also, Shaji, whatever you talked about the chips for smart cards and energy sectors, which have to be indigenized, that is very important because a lot of things can be taken away. But one more material other than silicon, for defense and strategic application, silicon carbide. Are we, any company or any design or any guys in this forum, are looking into the silicon carbide based chips which are very, very critical for our strategic sector? That's my question. Thank you.
Yeah, I mean, I think there's a lot of people looking at silicon carbide now in India.
It's highly refractive and the conditions are very different. You need 2400 degrees centigrade to grow silicon carbide.
So you're talking about manufacturing. There is a project that was approved under the ISM in Odisha that is doing silicon carbide. We have, together with Keynes, have acquired a power module company. We are doing silicon carbide ICs and then building power modules. I think silicon carbide is, in a way, actually the global market is going through a glut. It was so heavily hyped that, or actually it wasn't hyped, but the forecast for it was much bigger than the reality, and then on top of it, the Chinese put in double the capacity of the forecast. So it's, the good news is the price has crashed, so everybody can use silicon carbide now. But yes, silicon carbide is good, but you should look at, you know, as a material science, you should be looking at future, gallium oxide, gallium nitride, diamond. Those are the future technologies 5 years from now, 7 years from now, that will come into play. And
Yes, sir.
DRDO has a good program under GaN and silicon carbide.
On IP, I just small comment on IP. You see, India's next decade should be product creation, because IP, frankly, is a very insidious area, and you all know what I'm talking about. We face the brunt of IP sort of off the record we call it the IP mafia, and we have a special body for that, the Center for Intellectual Property Studies for Electronics, which is co-chaired by Dr. Sharma and chaired by Justice Shiv Kirti Singh, who was a Supreme Court judge and the Chief Justice of UP, and then TD Sat chairman also. So that is another in fact, the product guys have to be wary about that and very careful, because please let us know the challenges, because we are working on changing the complete environment, training the judiciary, having special benches, although some of that is not working in favor at the moment, because there are IP lawyers who have graduated and become judges and so on. So it's a work in progress, and I think we are just at 2, 3 out of 10 at the moment. But we need your inputs and support, because you see, as we are coming up, they'll go after you. The IP guys will go after you, and those are not product engineers, etc. They are a whole bunch of lawyers who it's like that amoeba getting produced, and this is not something we should be focusing on. The country will also not really support that. It's really products that we need, design products which we have to support. Thank you.
So, just one quick question, Mr. Raja, just from your point of startups and the support to them, and you mentioned one of them is dying. I've just been hearing, not from the tech side, but I'm thinking more from where the scale is, and I'm simply thinking from first principles. India is producing millions of washing machines, cars, ACs, two-wheelers, and I think if there is a wave, and if with the support of reference designs which are set up and support of business ideas, and existing manufacturing and creating smart products from at scale, and with some initial support, India could start building something, for the world, and then with the progress we have on the software. I'm just thinking that how do you finally make it, go beyond mobile phones, and how this whole ecosystem can come together. And so, yeah, just an idea which crossed my mind. I thought I should share it. Yes.
I think you hit it on the nail. My view is this, right? You want to make a product for the world and all that, right? It's a noble cause, and I think eventually we'll get there. But the route to go there, in my view, is you target the Indian customers, right? Indian products. Say for example, right? You talk about white goods, right? There's a little microcontroller in all of those, right? We can target that, and for an Indian use, right? You can take out a lot of the features there, make it for under $5, right? Under $5, most foreign companies will not be interested to sell in that. They want to sell expensive stuff, right? So you target those kind of things, and you have a market. My view is, if you're able to make our Indian system people, system companies, whether they are making inverters or they're making white goods or they're making BLDC fans, whatever it is, right? Our goal as a semiconductor company in Indian semiconductors is to make them successful, and they will take you global, right? Eventually they will take you global. So the chips inside is what you sell. I think somebody talked about this, right? Infineon or whoever it is. They make the product. I mean, they can make the end cars and so forth, right? But ultimately they sell the chip. So my view is, focus on the Indian market, see what we can do that will definitely, we will have an advantage through all these policies and so on. We have a huge market. And I can tell you personally, my experience so far, when I meet with the Indian companies, the Indian, system companies, they're happy to work with an Indian chip company because all the geopolitical issues that are going on. So I think, the timing is right. You target these and, you work on, obviously, the cost always becomes a factor. And that's where I said, I kind of said, the Tata should give us if they're selling to some other people $1,000 a wafer, maybe for an Indian company, they give it for $800 a wafer, So things like that, I think, so we target the Indian companies, they will take you to the global market.
Ajay, Utpal is right here. You can negotiate if you want.
Yeah. I think we are at the top of the hour, and I think if I continue any further, they'll start charging me by the minute, and I will not be able to afford them. But as a habit, I would want to end this by putting them in a very uncomfortable spot. And as a habit, I would also want to connect everything to Bollywood, Hollywood, and cricket. I would want to ask one question to each of the panelists and put them in a very uncomfortable position. No pressure, just fun. Start with Ritesh. So Ritesh, if Axiro Semiconductor had a theme song, what would that be that'll rally the Fabless design troops?
Okay, interesting. Well, the first song that came into my head is All Is Well, because it's the optimism that we need to, keep moving forward. But I guess on a serious note, maybe it would be Chuck Day India. I was just hearing it on my drive to here, because essentially all of us sitting here are, be it the government, be it academia, industry, MNCs, all of us are playing on the same side. Of course, there are things related to ROI, RRR, IRR, and all that, business-related things. But we wouldn't be sitting here if it was not about nationalism, if it was not about patriotism. And we want to see India on that podium. So I think on a serious note, it would be Chuck the India. Thank you.
Very well said. I think that'll... You have to sing the song. Dr. Narasimhan, if I have to ask you, what is the most weirdest policy idea that will pitch to Indian startups that they become the Indian wizards, semiconductor wizards?
0% capital gains on equity for sandboxes.
I might turn... Thank you so much. Coming to Utpal, if Tata Electronics was a superhero, what superpower would you use to zap the semiconductor design powerhouse firms' challenges in the country?
Design. I think we spoke about it already. I think getting some kind of an accelerator in place where there is zero cost access to EDA, IP, prototyping, silicon, MPWs. But I want to take this opportunity to say, on the manufacturing side, if we were a superhero, we would want a Sinchu Science Park type of ecosystem overnight in Dholera.
I mean, I wish you that.
It'll happen.
It'll happen. Coming to Sandeep. So what is the most unusual project that you've managed in L&T or across your career? And you also, I have to answer another question. What is this? Which sci-fi movie inspired you to get into the semiconductor business?
Sci-fi movie तो नहीं थी वो दो प्रोफेसर थे IIT दिल्ली में SC दत्ता रॉय और AB भट्टाचार्य. I think those are the two who inspired me into semis. मगर वो sci-fi से कमाल के हैं. They are equal to sci-fi. The craziest project, बहुत सारे crazy project किए हैं. मगर एक आया था चिली में एक project था. It is the driest desert in the world, Antofagasta. और उस टाइम कॉपर के दाम बहुत बढ़ रहे थे. It is also Chile also produces 40% of the copper. तो वो पहाड़ों पे कॉपर माइंस पहाड़ों पे होते हैं, उसके लिए बहुत पानी चाहिए होता है. It requires a lot of water. But लोग भी चाहिए होते हैं, वो लोग बीच पे रहते हैं चिली पे. There was a huge influx of people. And the water, because it's driest desert, it comes down. उन्होंने कहा कि पहले पानी नीचे आएगा, फिर यहाँ से पंप होगा वापस for mining. Because if you consume it for mining, it is not available. उसको करने के लिए फिर डीसैल प्लांट लगाने पड़े, उसको करने के लिए फिर मेम्ब्रेन बनाने पड़े. तो that was a huge semiconductor system project that I did. ऐसी अलग-अलग चीजें में पूछ जाते.
बहुत amazing. सूरज का
point is के most innovation and most thinking comes from systems. अगर आप system को समझोगे, वहाँ से शुरू करोगे, you will crack problems that are nobody else can crack. And not only that, then you capture that market. चाहे वो सेल फोन का प्रॉब्लम था, पहले उससे इतना बड़ा मोटरोला का फोन था, वॉकी टॉकी. The first time it was cracked was because of a system and we made a chip.
For example, in our team in automotive, we build automotive IPs, but the saying is think like you're building a car, right? And then come down and see what you have to basically build in the technology.
Sandeep reminds me of my professor. We put him in a very unusual spot and asked him to play cricket with us. He related all the points to saying how should you implement this cricketing tips into your education so that you pass out as an engineer and not become a cricketer. So yeah, what do you, Suraj, if I have to ask you, if ARM's IP were a dance move, what would
dance move?
Dance move.
Oh God.
What would it be to groove India into the global chip market?
Okay, I hope Pankaj doesn't ask me to dance now. But, dance move. Well, ARM has been around for 35 years. As what Sandeep just said, it's evergreen, so it has to be one of the Amitabhs or some evergreen dance moves that we all are aware of.
Thanks. Raja, what is the most out-of-the-box hack that you have used in IVP or elsewhere to survive the startup jungle? Or you advise them?
See, I can't afford to pay people as much as some of these established companies can, right? So I have a very, very fixed budget, and so I try to convince them about how great it is to work for a startup and that you can make decisions yourself. And getting all of this aligned and all that, which a lot of the bigger companies may have trouble with. So that's the song and dance that I need to do. In most cases, I think that they believe me, but I've come across people that is Raja is full of BS. But that is one of the challenges I have, and maybe you need to build some credibility there.
Thanks, Raja. Thank you so much. This was fabulous, and thank you for the stellar panel for sparking this discussion. I think we have wired together the Indian design talent, policy amplifiers, and innovation rhythm, providing that SoC, high-end SoCs are in sci-fi, but our next real hit. So let's switch on to the ideas and dance along the policy tunes. Yes, I said dance because Suraj, if ARM's IP were a dance move, it used to be Can We and Amitabh Bachchan steps. Thank you so much. Thank you everyone. Thank you audience for listening us patiently. A huge round of applause. Thank you.
Hello. I request the panelists to please be on the stage so while we present our mementos. So wow. Thank you so much everyone for such a rich and insightful discussion, and Sujay sir for adeptly moderating this entire session and your quirky questions as well. I would request Pankaj sir to please come on the stage to felicitate each of our panelists and moderators. First we have Dr. Sandeep Kumar. Please give a huge round of applause everyone. Next, we have Mr. Utpar Shah. following that, Mr. Raja Manikam. Dr. Ritesh Jain. Dr. Narasimhan. Mr. Suraj Gajendra. And finally, we have Mr. Sujay Shetty, our moderator. Thank you everyone for being here. May I now invite our panelists, moderator and Pankaj sir to please come forward for the group photograph. Thank you everyone. So Dr. Narasimhan from Cyient Semiconductors has a special announcement to make at this point.
I think while there are many accomplished people here, we were also given an opportunity to discuss about the startup ecosystem. I think it would be appropriate to call out one of us who is in the room at the back, who is doing some amazing, he and his team are doing some amazing work at the ground level as part of a government organization to try and get a lot of startups to get connected to the larger organizations. Dr. Abhay George of CDAC at the back, please give him a big hand. He's sitting quietly at the back and listening to all of us giving the lectures. Thank you.
Thank you, sir, and thank you, Abhay, sir, for being here. To conclude the event, I now invite Mr. Kapil Gupta, Associate Director and Fellow at ICEA, and one of the powerhouses behind today's event, to give the vote of thanks.
Thank you so much. Respected Shri Pankaj Mohindroo ji, Dr. Sharma ji, Dr. Sandeep Kumar ji, distinguished panelists and moderators, colleagues and esteemed guests. It is both an honor and a privilege for me here to deliver the vote of thanks at the close of today's landmark event, our launch of Product Design Leadership Forum. At ICEA, we always believe in creating platforms that not merely discuss possibilities, but actively shape outcomes. Today's deliberations have also shown us that India's semiconductor journey will be driven by persistence, collaboration, and vision. My deepest gratitude to Shri Pankaj Mohindroo ji for his relentless vision and leadership, Dr. Sharma ji for his persistent guidance, Dr. Sandeep Kumar ji for his leadership and his team, ICA team whose hard work has made this event possible, and all of you who have joined us today. Thank you so much. Finally, before I keep you away from your lunch any longer, let me just close with timeless words of Bhagavad Gita, a slok that captures the collective spirit of action and persistence. Karmanye vadikaraste ma phaleshu kadachan ma karma phale heturbhur mate sangotsva karmani You have the right to action alone, but you never have the right to the fruit. Don't be motivated to act because of the fruit, but don't be motivated to not acting either. These words remind us that while outcomes will follow, it is our duty to act with vision, passion, resolve. Thank you all once again.